give you a chance to do a few investigations to see how thermal energy is unevenly distributed through the Earth. There's uneven heating on the Earth, which causes weather to happen. And so we wanted you to use the globe and a flashlight, shine the flashlight on the equator, and then move it to the North Pole, to the South Pole, and notice how the beam of light looks different on the equator compared to the poles because of the curve of the Earth. And we want to talk about uneven heating is caused by different shades. If you have land that's darker than snow-covered area of the Earth, there's going to be a difference in temperature because darker colors are going to absorb more radiation and convert it to thermal energy than lighter colors. But you need to prove that with this equipment. You've got 3 different shades of bottles here. You can add the same amount of water, or you can just leave it as air with the thermometers. Write down your initial temperature, and after 10 minutes, find out what the temperature change was. Which one of these heated up the fastest? You could use these 2 little convection bottles right here. Does the same thing, I just don't have a gray one. Turn the light on them for about 10 minutes. Watch the change in temperature. Which one heated up the fastest? There's going to be some uneven heating. You see, in order for there to be weather, there has to be uneven heating. There has to be warm air and cold air. And also, how about soil or continents versus the ocean? You can add water to this to represent the ocean, and this to represent the land. And the question is, which heats up faster? Make a prediction ahead of time. What will heat up faster, the land or the water? And so you would control all your variables, same amount of water, same amount of land, same thermometers, same distance from the lamp, which is a model of the sun, same distance, go for about 10 minutes, write down your data, check your temperatures every minute for all of these. Check your temperatures every minute for 10 minutes, create your data table, and then maybe you can change the data table into a graph as well. And remember, these are models. Scientists use models a lot for things that they can't hold in their hands. We can't do an experiment on the whole world, so we use a model of the world. We can't actually grab the sun, so we use a flashlight for this. Convection current models right here, as you can see. It's a model of convection currents. We have warm fluid rising from the heat source. When it cools off, it becomes denser and falls back down. It's a continual cycle. That's called a convection current. Convection currents cause weather. Convection currents cause ocean currents. Convection currents even cause magma inside the Earth, scientists believe, to move around and create earthquakes and movement of plates. Just one last thing is just think about a fair test. When you're working with this, everything has to be controlled. Same distance, same amount of liquid, same thermometers. You want to keep everything the same except for the one thing that you're really testing, which is in this case different shades, water versus soil. Those are your independent variables. Everything else you got to control to make it a fair test. So have fun studying convection currents, have fun studying thermal energy, differences in thermal energy. Without differences in the amount of heat in 2 different places, there would be no movement at all. No weather, no wind, nothing. Bye.